Let us begin a question-answer session on network, the third lecture in this series. First question: what is supernode? The answer: consider a portion of network between nodes A and B. Let there be a voltage source between the nodes A and B. Resistance R1 is connected to node A and resistance R2 is connected to node B. Let this be R3 and this resistance be R4. This point denoted by R is the ground. Voltage at node A is VA and voltage at node B is VB. Let current across R1 resistor be I1, flowing towards node A. Current across R3 is I2, flowing out from node A. Current across R2 is I3, flowing towards node B, and current across R4 is I4, that is flowing out from node B. V denotes voltage source. R1, R2, R3, R4 are resistances. Small r is the reference node, while A and B are non-reference nodes. So R, A and B are the nodes. Let us indicate the voltages at the nodes. At reference node, the voltage is VR and it is taken to be 0. Since it is a reference node, the voltage at node A is VA and the voltage at node B is VB. We note that the two non-reference nodes A and B have a voltage source V in between and they form a supernode. Let us call it AB supernode. We can apply Kirchhoff's laws to supernode AB. If we apply KCL, that is Kirchhoff's current law, to the supernode AB, we get I1 plus I3 equal to I2 plus I4. Note that I1 and I3 are currents entering the supernode, while I2 and I4 are exiting or leaving the supernode. Apply KVL to supernode, that gives VA minus V equal to VB. Next question: find I1, I2 in the circuit that we draw now. This is 80 volt voltage source. This is 5 ohm resistance, this is 50 ohm, and current is along this direction denoted by I1. This resistance is 10 ohm and this is a voltage source 75 I1. In fact, it is a current dependent voltage source and this is a 15 ohm. Current across 10 ohm is I2. This node is grounded. The options are: let us solve for the answer. Given circuit is, let us redraw it. Combined series resistances 10 ohm and 15 ohm, that gives 25 ohm. So with this, let us draw the circuit, and here it is. Nodes are A and B, and here are they, A, and this node is grounded called B. The voltages are VA and VB equal to 0. Let current in this branch be I3. Apply KCL to node A. It gives I1 plus I2 plus I3 equal to 0. Note that all these currents I1, I2, I3 are away currents. They flow away from the node. Now I1 is VA minus VB divided by 50 ohm. As current flows away from the node A, we place VA first and then VB, and VB is 0. I2 that flows away from node A is VA plus 75 I1 divided by 25 ohm. This is I2. Now I3, it is VA minus 80 volt divided by 5 ohm. Set up the equation. This is VA by 50, it is I1. In the second factor, replace I1 by VA by 50 and we write, simplify, we get VA by 10, which is I2. We shall require these expressions of I1 and I2 soon. Hence KCL leads to VA by 50 plus VA by 10 plus VA minus 80 by 5 equal to 0. Simplification leads to VA equal to 50 volt. So we are in a position to find I1, which is VA by 50, that leads to 1 ampere. I2 is VA by 10, that leads to 5 ampere. So I1, I2 will be 1 ampere, 5 ampere respectively. So the answer is this one. Next question. Find the value of I, I1, I2. Let us draw the circuit. This is a 60 volt voltage source connected to a resistance 20 ohm. And this is another voltage source, a current dependent voltage source to be particular, of value 10I. It is connected to resistance of 4 ohm. Current here is I1. Current of I enters a voltage source of 40 volt. This resistance is of 4 ohm. Current in this arm is I2. What are the options? The options are the answer now. Let us redraw the given circuit. Here it is. Apply KVL to first loop, which is this one. Let us move clockwise, say, to get 60 volt minus 10I, this being the current dependent voltage source, equal to 20I1 plus 4I2. Call it equation 1. Now apply KVL to second loop, and this is the second loop. Let us circulate along I. We thus have 10I minus 40 equal to 4I minus 4I2. Simplifying, call it equation 2. Apply KCL to node A, and A is this node. We get I1 equal to I plus I2, where I1 denotes current that enters the node A, and the currents I and I2 are leaving node A. This is equation 3. Let us write the three equations, equation 1, equation 2 and equation 3 at one place with the aim of solving them. Replace this I1 by I plus I2. This gives, on simplification, equation 4. Let us encircle to highlight it. Now we quote equation 2. Multiply by 2. This gives equation 5, and let us highlight it. Equation 4 minus equation 5 gives minus 30 equal to minus I. So we get I equal to 30 ampere. We quote equation 2 once again. Put I equal to 30 ampere. Simplify to get I2 equal to minus 35 ampere. Again, from equation 3 we have I1 equal to I plus I2, which is 30 ampere minus 35 ampere, and therefore I1 is minus 5 ampere. So I1, I2 have values 30 ampere, minus 5 ampere and minus 35 ampere. Now we are in a position to strike the correct option, and it is this one. Let us switch over to the next question. Find VA, VB and VC in the circuit that we prefer to sketch now. This diamond represents a voltage source, a voltage dependent voltage source. Here is a current source. This is of 2 ohm and the current source sends current of 8 ampere. The voltage we referred to previously, on which the voltage dependent voltage source 0.8 V0 depends, is here. It is V0, the drop across 5 ohm resistance. This terminal is grounded. This resistance is 2.5 ohm. This is another current source of 5 ampere. Voltage at this point is VA, at this point it is VB, and here it is VC. The options are: the answer. Given circuit is, let us redraw. The nodes are this is the reference node. Voltage here is VR equal to 0. Other nodes are A, B, C. They are non-reference nodes and the voltages are VA, VB and VC. We see that A node and C node involves between them 0.8 voltage source. We treat AC thus as a supernode. Apply KCL at node B. This gives 8 ampere. This current is entering the node B. Let I1 be current in this branch across 2 ohm and I2 is the current across 5 ohm. And across 2.5 ohm we have I3. Let us get back to complete the KCL relation which we started to write. The right hand side will be I1 plus I2 and these currents are leaving the node B. What is I1? I1 is VB minus VA divided by 2 and I2 is VB minus VR by 5. We know that R node is the ground and so VR is 0. So the equation as per KCL becomes 8 equal to sum of these two terms. Simplifying we get 8 equal to 0.7 VB minus 0.5 VA. Call it equation 1. KCL to supernode AC gives 5 ampere plus I1. These currents are entering the supernode AC at A equal to 8 ampere plus I3. These are currents leaving the supernode at C. Now what is I1? It is VB minus VA by 2. And what is I3? It is VC minus VR by 2.5 with VR equal to 0, it being the reference node. Complete the equation for KCL. Now we simplify to get 0.5 VB minus 0.5 VA equal to 3 plus 0.4 VC. This is equation 2, let us call it. Apply KVL to the supernode AC and we get VA minus 0.8 equal to VC. This is equation 3. We have got 3 equations and let us write them at one place for solution purpose. This is equation 1, this is equation 2 and this is equation 3. Equation 1 gives 0.7 VB equal to 8 plus 0.5 VA, which gives VB equal to 11.43 plus 0.7 VA. Equation 3 gives VC equal to VA minus 0.8. And equation 2 gives, we replace VB by 11.43 plus 0.7 VA and also replace VC by VA minus 0.8. This gives VA to be 5.53 volt. And so VB is 11.43 plus 0.7 into 5.53 for VA. We get 15.3 volt for VB. Again, VC is VA minus 0.8. This gives 4.73 volt. So VA, VB and VC, let's collect the values and write. With approximation 6 volt, 15 volt, 5 volt respectively. So this is the correct option.